Good morning. So hopefully you guys got through the last lesson okay. I have been told by pretty much everybody that you guys went over Bohr models and Lewis dot structures like pretty well in physical science. So I wasn't expecting that. Last year's students, about half of them had done it and half of them hadn't. So I was kind of expecting the same thing this year. So if that's the case, hopefully that was a super easy lesson for you guys and it all started coming back to you. So today we're going to build on that with electron configuration. Again, I'm not sure if you guys have done this or not. Last year, no one had, but obviously some things had changed since then. So we'll just go through this, and if you guys remember it, that's awesome. And if it's brand new, that's fine too, because we're going to start from the beginning. So we talked about last class how the actual formation of an atom, all the electron clouds basically kind of are in these shapes. Okay, so you have this multi-layer formation here with all the different clouds or areas of probability where the electrons would stay. So we were using Bohr's model to describe kind of the different layers of that last class, but electron configuration is a much more specific way to describe the location of electrons within their orbitals. So that's what we're going to do today, is figure out how to show that. Talk about kind of the movement of the electrons and how we can represent which orbital they're on. So we're going to start off with Aufbau principle. Okay, so again, another scientist. Everything's named after scientists. If you guys discover something, science classes will talk about you for years to come. But Aufbau's principle, I must have accidentally erased. Nope, there it is. Okay. Basically, it's nicknamed the lazy tenant rule because electrons are always going to fill your lowest energy level first, which we know that already. You did that with your Bohr model. So you filled up the first ring and then you moved on to the second ring and then the third. So it's the same way with electron configuration. You're representing the same information. It just is in a different way. So if you look at this crazy looking chart here on the right side, this is the order that you will be writing out your electron configuration. So notice how these numbers increase as you go down. So this would be like your first ring, okay? Your second ring, your third ring, your fourth ring, fifth ring, sixth ring. So as you go, you can see that there's kind of like multiple layers within this. This is representing, let's go back, these. Okay, so like this, all these like little figure eight looking shapes that are sticking out here like a jack, these are representing the p suborbital. So these are all three of them are representing like your second ring basically on a Bohr model. So you have different areas of these. Okay, so you have like this would be the first section, only 2 electrons can fit on this. So then you'd have more on this section, only 2 electrons can fit on there. So that's what these like S and P and D and F are representing. And this will make more sense once we get talking about sections of the periodic table. So again, with Aufbau's principle, it's a lazy tenant rule. So basically, if you think about it like a house or something, so if you are a lazy tenant and you don't have an elevator in your apartment, you don't want to live on the 3rd floor, right? Like there's no elevator, no way, you're not going to live on the 3rd floor. You're going to be like, hey, can I have that first floor apartment? So then if another guy comes along, 1st floor is filled up now, his only options are 2nd and 3rd. Well, he's not going to go to the 3rd floor either because there's no elevator, it's only stairs. So he's going to say, okay, I'll take one on the 2nd floor. Okay, and then another guy comes by and he says, okay, I need an apartment. Well, if all these floors are filled up, he's going to have to take the last one. So think of it that way with your electrons. You're going to fill them up from the lowest energy level and work your way up. This also has to do with what we talked about with de Broglie and the energy, the frequency of those electron waves that he was showing there. So you have to have more and more energy to get further away from the nucleus. So they're always going to try to stay closer to the nucleus if they can. So then we come to Pauli exclusion principle. So we have kind of briefly touched on the fact that you kind of have some of these variables that represent different things about the atoms. So N is our energy levels. Okay, we have talked about that. So each ring is kind of represents 1N, 2N, and goes up. There's a shape of a sublevel. Okay, so the shapes of the sublevel are, let's go back here, these. Okay, so these are all obviously different shapes or different arrangements. Okay, the orientation of the orbital around the axis, so the way that it is angled kind of around the axis there, and then the spin of the electron. So what the Pauli exclusion principle is saying is that no electrons have the same 4 quantum numbers, and these are the quantum numbers. So it's not actually a number necessarily, it's kind of like these 4 qualities. Okay, so no 2 electrons are going to be in exactly the same position ever. That's what that's saying. So they're never going to be in exactly the same position. So here's another example. This is an example of like an orbital diagram. So we know that there's 3 different p orbitals. So again, we'll talk about this again. These are the shapes of that first diagram that I showed you. So you have like these 3 different angles and shapes, and these little arrows would represent the electrons that are within those. So even though like these would all be on the p sublevel, which I'll explain in a second, so even these would all be in the same sublevel, they're not going to be going the same angle as anything else in here. And even with these 2 that are on the same sublevel, they're going in 2 different directions. So each electron in an atom is going to have its own specific set of characteristics or qualities to describe its location. So with electron spin, like I was talking about, you had the up and down arrows here, up and down. This is describing the way that electrons move within their sublevels. So any orbital can hold 2 electrons, and the electrons spin in opposite directions. Okay, so this gives you here like +1/2 or -1/2. This is just describing the directions basically with going opposite directions here. So if you look here, you have north at the top and south at the bottom, and then this one's flipped, going north bottom, south up. So if you flip this back over, they would be going the same direction, right? So here you've got, here, this one's kind of hard to see, but this shows the electrons spinning in different directions a little bit. This was not the best animation, but it was all I could get a hold of for this. So just know that the electrons are going to be spinning in opposite directions. So if you have 2 electrons, let's see. Oops, actually I could show you on this one. So like here on these little p orbitals, so you have 2 electrons on here. If one is spinning this direction, the other one's spinning the other direction. Okay, so just keep that in mind. The electrons will always spin opposite of each other. So that brings us to the electron configuration. So again, the purpose of using electron configuration is to give a specific description of where electrons are found on the periodic table, or where the electrons are found within each atom on the periodic table. And so if you look at this periodic table, it's labeled for you. So 1s here. 1s describes this whole entire top level. Okay, so it does include helium. Helium's over on the right hand side because it's stable, but truly it fits right here in this little blank area. So helium is part of this s sublevel. Okay, so then you have 2s. Okay, so then this is the next sublevel, and if you remember from last class where I took you through all the different sublevels as they layered on top of each other. The slide was like black and it had different colored orbitals on it. This is what this is showing. Okay, so the 1s was the first sphere, the 2s was the second sphere, and then when we started adding those figure 8 shapes, that's when we got into the p orbital. Okay, so you go from 2s, so this whole blue section is the s sublevel, and then you get over here, and you go into the P section. So this whole green area is the P section. This is 2p. So if I was going to describe carbon, which is right here, I would say it is 1s2, because I went through both of them to cross down. 2s2, because I crossed both of these. 2p1, 2. Okay, now I would stop here. So the whole thing would be 1s2, 2s2, 2p2. Nitrogen would be 2p3, oxygen would be 2p4, and so on, okay? So you are literally just describing exactly where all of the electrons are on every orbital. This over here shows you the pattern that you can follow to do that. So if you're not sure where to go from here, like once you cross through 1s, you come back to the top and you're going to cross through 2s. Then you cross through 2p and then 3s, and then 3p and then 4s, and you continue. So if I needed to, let's get my pen here. If I needed to do this, I would say, okay, I'm going to go this way, all the way across, and then through these, that's my S, and then I'd go all the way through this. Let's say I'm going to go, I don't know, let's go to chlorine. Then you go all the way here, and you would stop here. Okay, so if I was going to write that out, I would say 1s2, 2s2, 2p6, because I crossed through all 6 of these. Now I'm down here, so I'm going to have 3s2, because I have to go across those. Now I'm down here. Chlorine is the 5th one over, so I'm going to say 3 for the level I'm on, P for the sublevel I'm in, and then 5 for how many electrons I've counted across. This would be the longhand version of the electron configuration. Okay, so this is telling you that there are 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17 electrons. Okay, so all of your superscripts here are representing your electrons, which matches this. Okay, so you've got 17. So within this, you have the number in front is representing which row you're on. The letter represents which orbital you're talking about. And then the superscript describes how many electrons there are in that section that you've went past. So one thing that is different that you want to take into consideration is down here, when you go from 4s to D, red's not a good color for that, but when you go from 4s to D, this goes from 4 to 3. Okay, and that has to do with the way transition metals are positioned on the periodic table. So they are essentially like moved down in here because they follow trends that go along with things like zinc and gallium, like the trend of like electronegativity and atomic radii, and there's all these different trends that we'll talk about. So it's positioned down lower than the row that it was in because of those things. So to account for that, we're talking about this would then go to a different orbital of 3. So when you go from 4s to 3d, and then when you come back over here from zinc to gallium, you would then go from 3d back to 4p. Okay, so then if you went all the way through, you went through 4p, let's come down, we're in 5s, 4d, 5p, 6s, 5d, 6p, 7s, and then, I skipped these, sorry. So you go from 6s down to 4f, okay, because we know, hopefully, that this section down here, the other elements down here are really positioned right here between these two. Okay, so this whole section fits right here. It is positioned down here for ease of use, but you can find like the elongated version of a periodic table and it would fit right here. So when you're writing these out, if you follow this pattern over here, it kind of helps you keep track of that. Okay, so if I was going all the way down to like mercury, okay, all the way down here, this is how I would read it. I would say 1s2 because I was in level 1, s was the sub level, and then I went past 2 electrons. 2s2, 2p6 because there's 6 across, 3s2, 3p6, 4s2, 3d10 because there's 10 across here, 4p6, 5s2, 4d10, 5p6, 6s2, and then here I'd go all the way across to mercury. Okay, so hopefully, let's erase all of this. Hopefully You guys understand that? Okay. So when you guys are going across here, just make sure you're following this pattern, okay? So like here, when you get all the way down to 4D, you go 5P, 6S, 4F, 5D, 6P, 7S, 5F, 6D, 7P, okay? So again, kind of a different way to look at this here. You've got your different orbitals labeled pretty clearly for you for all these sections. And remember that helium really belongs over here. So 1 is your quantum number, which the quantum number is talking about like which level you're on. So the quantum number goes along with the orbital and you're like a Bohr model. S is your orbital angular momentum, which you don't need to know maybe the definitions of these, but just understand that this is talking about the shape of that sublevel. So S would be a different shape than P and D and F. And then the number of electrons goes up here in your superscript. So that's talking about basically simplified how many spots you've gone over within that sublevel. All right, so if we're going to represent these with our orbital diagrams, if we have oxygen, sorry, I gotta get all this up here. Whoops. So oxygen has 8 electrons, okay? And the electron configuration would look like this. So if we looked at that periodic table, we'd have gone through 1s2, 2s2, 2p4. You would stop on 4 because oxygen is the 4th one over. So electron configuration is this, and then the orbital diagram is represented here. So if we were to represent each electron using an arrow, they're going to be up and down arrows. And we have to follow all the rules that we've gone over so far. So Aufbau's principle, we're going to fill up each sublevel before we move on to the next one. So if we have 2 electrons in the first sublevel, one will go up and one will go down because they have opposite spin. And then for the second sublevel, you have 2 electrons here. So one will go up, one will go down. For the third sublevel, or well, these are really one big layered sublevel. So for the third section here, we have 2p. You have 4 electrons. So you're going to put 1 in each spot and then come back in and put another one. Okay, so for the p sublevel, p can hold 6 electrons. So when you're representing it with an orbital diagram, you need as many boxes as half as wide as the sublevel is. Okay, so like S can hold 2, so you need 1 box. P can hold 6, so you need 3 boxes. D can hold 10, so you need 5 boxes, because only 2 electrons will fit into each one. So kind of bouncing off of that, we have Hund's rule. Hund's rule is the empty bus seat rule, so it's kind of similar to Aufbau's principle. So within each sublevel, only 1 electron per orbital, and then you go back in and fill it in, okay? So and I'll explain this kind of this nickname for it in a second. So this would be the correct way to do this, right? So you have an up and a down, you have an up and a down. So this is Aufbau's principle. We filled up this sublevel before we moved on to this sublevel. We filled this one up before we moved on here. But Hund's rule explains that you're going to put 1 in each box or seat before you start filling them back in. Okay, so this would be wrong down here, to have an up and a down and then have a blank space over here. And again, this is representing nitrogen, okay? So you'd have 1s2, 2s2, 2p3. So you'd have an up, up, up. This is representing how the electrons are spaced out within each orbital and that they balance each other out. So it goes with the empty bus seat rule, okay? So if I have my little pen here, so let's say somebody comes in and sits here, okay? If you come in and you're following Aufbau's principle too, so you're lazy, you don't want to go all the way to the back, you want to sit in the front, but you're not just going to get on a bus and sit next to somebody you don't know. So you would choose probably to sit in the front row, but over here. Let's say another person comes on, also lazy, they don't want to walk any further than they have to, so they're going to pick up something in the front row. Well, now they'll come in and sit next to somebody because there's no other options. Since somebody else would come in and sit here. Now the next group would go here. This guy would sit here. If somebody else gets on the bus, they're not going to sit right next to somebody else you don't know. So he's going to come and sit on the other side. And then you would fill it in as you go. And then it would work that way as you work your way back. Okay, so you're never going to put 2 arrows next to each other unless everything else is already full. There you go. Okay, so you'd fill it in like that. So over here shows that as well. So these are different atoms as you go down. So you have lithium through neon. So it gives you a lot of information here, a lot of examples. So the electron configuration for lithium would be 1s2, 2s1 because of its position. You'd represent that here. So 1s, you'd have an up and a down. And then for 2s, there's only an up, and there's 3 arrows, there's 3 electrons, you're done. If you work down to a bigger one like oxygen, okay, so it's 1s2, 2s2, 2p4. So if we have this, you'd have 1s2, okay, so an up and a down representing opposite spin in this orbital. For the second orbital, you have an up and a down. And then when you come over here to p, this orbital will hold 6, so that's why there's 3 boxes across here. We know that we're only going over 4 places, meaning that there's only 4 electrons in this outer orbital. So you're going to have an up, 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 and then you would come back in and put it down. Okay, so you would not have like an up and a down and an up and down here with this one blank. You will put one in each spot before you start filling them back up. Okay, so this is, let me erase this. This is going to be the last page. I would use this as guidance as you're working. And if you get on ptable.com, write this here. So that yellow is not a good color for that. Okay, so p table, I don't have my tablet set up to write, so this is messy, but ptable.com, it's literally just the letter P in table. That's a really good online periodic table that I would recommend using. So if you use that, the electron configurations are listed. I think. So they should be. If you click on it or something, you should be able to find the electron configuration within that. So that's a good way to double check yourself. Or if you're like need more examples, you can do that. But again, follow this pattern. Okay. So if I'm trying to describe like bromine, okay, it has 35 electrons. So the longhand version of this is going to be 1s2 because we went through there. 2s2, 2p6, because we went across all of them, 3s2, 3p6, 4s2, 3d10, 4p5, because I'm stopping at bromine. Okay, so it's 1, 2, 3, 4, 5 places over. Now, there is one more thing to talk about. Oops. Let me see if I can add one more slide here. Hold your horses. Hold on a second. Okay. Sorry about that. So there's another way to write these. Okay. So the shorthand electron configuration will make your life a little easier as far as showing these. So if I did, let's do chlorine. Okay. The long version of chlorine is going to be 1s2, 2s2, 2p6, 3s2, 3p5. Okay, that's the long version of this. So that's going through and showing every single level. The short version basically just abbreviates it so that you can start from anything, any noble gas. So these are your noble gases. Okay, and then go from that point. All right, so again, if these are both going to be bromine. Oh no, chlorine. Whoopsie. Okay, so these are both going to be chlorine, UCl. So chlorine's here. So what you want to do is go over to the noble gases and go up one. This is where you'll start. So I'll start from neon. So I'll put neon in brackets, and start from there. So if I was starting from this point, my next step would be 3s, right? So 3s2, and then 3p5. Okay, so you basically, wherever you're at, you go all the way to the right hand side and up one. and that's where you will begin. That noble gas will be in brackets, and then you can start from there. So you can see how this would be useful when you come all the way down into these lower sections where maybe you don't want to write out 57 different electron configurations. So if we did like iodine, okay, the shorthand version for iodine, we would go over here to the end and up one. So this is krypton, so I would start with krypton. So Kr, put that in brackets, and then I just start from here. So this is like the 4 level, so I come down here. Now I'm in 5, so I'd be 5s2 because I'm crossing these two. Oops. Oh, hold on. I went too far down. So here, this is level 3, sorry. So krypton is in level 3, so you come down to level 4. So you go across this 4s2, and then straight across. Oh, this formatting got messed up. That's where I'm getting weird. I'm so sorry. I'm going to have to fix this. So you can see that these numbers, I didn't go with it, I guess, when I resized it. That's where it's messed up at. Okay. So anyway, so this is the 3rd row down. So you'd start here with the 3rd row. So this is krypton. Come down here, 4s2. This would be, oh no, this is 4. So this is 5. Oh my goodness. Okay, let's just hold the phone. Let me fix this and I will come back to you. Let's erase everything. Okay, life is together now. So sorry. That was a really bad example. Okay, so let's try this again. So let's say we're going with iodine again. So we want this one. I don't want to write all this out. I don't want to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p5. I don't want to do that. That's a lot. I want to do the shorthand version. So for the shorthand version of iodine, you're going to go to the noble gases and then up 1. So you would put krypton in brackets to begin. So I'd put krypton in brackets and start from here. Okay, so I'm in the 4th sublevel. So I'm going to come down here. And I'm going to go 5s2, 4d10, because I'm going all the way across, and then 5p5. So that's the shorthand version. So instead of writing the entire electron configuration out, by starting at this noble gas, it is assumed that everything before this is full. So you can say, like, you start with this noble gas, you know that every single row is already full of electrons. So instead of just writing all that, you just start here with krypton and move on. Or you would start with argon or neon or helium or radon or whatever. Okay, so it's the shorthand version basically. So give these a shot. You do have a gizmo to help go over this. I think the gizmo does a really good job of showing you the electron configuration with the orbital diagrams. It shows you the up and down arrows and how that shows the spin. It does a good job of showing Hund's rule of filling up each orbital first. It does a good job of showing Aufbau's principle of filling up each section before you move on further away from the nucleus. So get on Canvas, open up the gizmo. It's on a PDF and you'll have to go to explorelearning.com. Make sure you're logged in or else it'll only give you 5 minutes to work. But that's the only assignment. So you guys don't have any additional work to do with this right now. So this will be your practice for it. So please put in some effort. I know there's been a little bit of an issue of people just like copying it down, which to an extent I understand because you guys are using your resources and no one's there to see what you're doing, I guess. Like it hasn't been a huge issue, but it is your learning experience. So if you are just copying it down from a friend or like literally turning in the same document as someone else, it's not helping you at all. the homework's not worth very much. So if you're just copying and cheating on 5-point assignments, and then you get to the test and you have no idea what you're doing because you've copied all of it, that is not helpful to you. Okay, so I get it. You guys are busy. Sometimes the easy way out sounds nice, but don't hurt your own educational process trying to get the easy way out. Okay. And I'm not talking to everybody, obviously, but I've noticed it with a couple of people. So just keep that in mind, that that's important, that you want to have some integrity in your work because it's beneficial to you. So try out the gizmo. Please let me know if you have any questions. This one, I will say, is I'm finding it difficult to try to teach in a video. So please let me know if you are getting stuck or lost. We can schedule a Zoom meeting and I can go over some things. Or if you have questions, like screenshot it and send it to me and I can help explain it, like specific problems. So go back through. You guys are going to be working on your orbital diagrams, your electron configuration, longhand and shorthand. And let me know if you have any questions.